Welcome to CE 273 or surveying. This will be the first video in my surveying series, taping corrections. We'll just be mainly doing temperature today. We won't be focusing on sag corrections or tension corrections, as I didn't see it on the final exam or the previous exams. So let's begin. Alright, so the first problem says that we measure about 170.58 feet using steel tape on a cold February day when it's 15 degrees and the wind chill is -5 degrees. So one thing to note right off the bat is that we don't use the wind chill. Okay, like we can just forget about the wind chill. That's irrelevant to us. We're just focusing on the current temperature that it is outside, right? So if I were to well, first of all, we need to know what equation we would need to use for the wind correct or the temperature correction, right? So the equation we want to memorize or want to have for our exam is, I got it right here. It's you got your tape correction, CT equals K, which is your constant based on the material of your tape, and then you have your temperature 1, or your ambient temperature minus the that's like the average temperature, and times that all by the length of the tape. Okay, so we can just plug it in. Well, first things to note is in this problem we want to use that K is equal to, it's a constant, 6.45 times 10 to the -6. Okay, that's our K constant for steel tape. Okay, and our T, not our T1, but just our T, our um, our baseline temperature, or our temperature we use to compare, is going to be 68 degrees Fahrenheit. Okay, so now we can just use this equation and plug it all in. So let's go ahead and calculate what CFT is. So CFT equals to 6.45 times 10 to the -6, and it's all multiplied by T1, which is our ambient temperature, which is not the wind chill, but the 15 degrees, minus our comparison temperature, 68 degrees, and it's multiplied by the length of our tape, which is 170.58. Okay, and now we can calculate what CAT equals. So if I plug this in if I plug this into the calculator, I get times 0.58 times by 6.45 e to -6. I get a negative 0.058, and this is in feet because this units we did it on feet. Okay, and the equation to find the actual length, because that's just our corrected length, right? So our actual length, right, would equal our length measured plus our correction. Okay, and make sure that we know what our signs is. The signs are important. So our actual length is equal to 170.58 plus our negative 0.058. Okay, so this gives us 170.52. I guess I could have done that in my head, but that is the actual length of our tape in these weather conditions. Okay, so for our next problem here, it's more of kind of like a conceptual problem more than a calculation problem. But let's go ahead and read the question together. It says, on a hot 98-degree day, over 10 tape lengths, or the tape is 0.19 feet longer than the theoretical 1,000 feet. If I measured 1,000 feet, how long is the true distance? So, if it's 0.19 feet longer than theoretical 1,000 feet, right? That means we actually measured true distance is equal to, you just add it on, right? Because it's 119, that's like our correction, that's basically our CT, plus our 1000. So that gives us 1000.19 feet. Okay? And then if I need to lay out 1000 feet distance, how long of a distance should I measure? So if I actually had a tape, right? If I had a tape that's this long and I measured out 1000, right? But the actual is actually 1019. I should subtract 0.19 from my actual or my physical measurement, right? So I would just take 1000 minus 0.19, right? And that will give us 999.81, and that is our actual feet measurement. Alright, so for our last problem here, it says that you are the timing official for the NHRA Drag Race Nationals, and you are marking the finish line and setting the trap sensors beams for a quarter-mile drag strip on a 98-degree day in question 10, but we can just ignore that. It's asking us how many feet from the starting line should you mark the finish line. So we know, well, first of all, how long should the drag strip or the length of the racetrack, like the actual length of it, be? So it says that it has to be a quarter of a mile. We're just going to do this in feet. 1 mile equals to 5,280 feet, alright? And then quarter of it, so it's just 1/4 times 5,280 feet equals to 1320 feet, alright? So that's how long our drag strip, or we want our drag strip to be. But we're going to measure it out using steel tape, so we need to find the correction of it, because if we measured exactly 1320 feet, it's going to be off. So let's go ahead and find the correction. So remember the equation, CT is equal to our K constant times our temperature minus the comparing temperature and the actual length. So now we can just plug in. So see, K is given, if you guys remember, it's the 6.45 times 10 to the -6 constant. And our T1's 98 degrees minus the comparison temperature, which is 68 degrees. And we multiply that by the length, which is what we want, which is what we calculate over here. It's 1320. Well, if I were to plug this onto my calculator, I'll tell you guys what I get here in a bit. 6.45 e to the -6. I get a positive 0.255, right? And that makes sense, because if it's hot, it's like a hot day, 98 degrees, your tape would probably expand, and if it was a cold day, it would shrink and therefore be a negative number. So now the actual length is just the addition of what we want, right? So our 1320. See, now we don't want to add this up, right? Because if we add it, I will add it right now real quick. That'll give us 1320.255, right? So if we measured out 1320, we'll actually have 1320.255, and that's a quarter too much. So we actually want to subtract of how much we want to measure, right? So 1320 minus 0.255 equals 1319.74 feet. Okay, that's what we actually want to measure out. Since on a hot day your tape expands, so it's actually longer than what the reading suggests the actual length is. And that's it for this video, guys. Hope you guys enjoyed my surveying series. It's the start of it, and there should be more videos to come. There weren't that many lectures, so thanks, guys.